This section covers graphing quadratics in what is called vertex form. The vertex form of an equation is y minus k is equal to a times x minus h squared. In order to start this, we are going to look at the most basic form of the quadratic, which is y is equal to x squared. The vertex is at the point 0, 0. What you're going to find in this section is that you'll be using a lot of the same techniques that we used when we were moving trig functions around the coordinate plane. So here, we've got y is equal to x squared. The dashed line is y is equal to negative x squared. So hopefully you can see that by adding this negative, we have turned our happy face parabola into a sad face parabola. In this next one, we started with y equals x squared. The blue equation, rather the blue graph, is y is equal to 2x squared. The red graph, y is equal to 1/2 x squared. We're going to start to recognize some of these same patterns. These are all happy faces. If we look at the ones on the bottom of the coordinate plane, the red one here is y is equal to negative 1/2 x squared. The blue one, y is equal to negative 2 x squared. Hopefully the pattern that you've seen is that if the coefficient on x squared is a positive number, then these graphs open upward, or we can call them smiley faces. When the coefficient on x squared is a negative number, the graphs open downward, or we can call them sad faces. We should also have noticed that when this value is larger, we get a skinny graph. When this value is a fraction, we get a little bit wider graph, and that's true whether it's positive or negative. So here our value is a greater negative number, so it's skinny, whereas this is a smaller negative number, so it's flat. The next set of graphs that you see, we're taking our parabola, which is again y equals 1/2 x squared. And the first thing that we did in the blue is we shifted it to the right 3 units. The way that we'll write this is y equals 1/2 of x minus 3 squared. The red one has been shifted to the left 3 units. So we can write that as y equals 1/2 of x minus negative 3 squared, or 1/2 x plus 3 squared. So the big idea here, and this was similar when we did trig, when we have x minus, we move right. When we have x plus, we move left. Here we're also moving these vertically. So we'll again start with y is equal to 1/2 x squared. To move up vertically, we just went y minus 3 is equal to 1/2 x squared. To move down vertically, we said y minus negative 3 is equal to 1/2 x squared, or we can write this y plus 3 is equal to 1/2 x squared. So again, the same kind of rules are applying. If we subtract, we move up. If we add, we move down. I always think of it as y minus some number. So if you minus a negative, you get a plus. So now we'll look at a couple of transformations. I'll start with the fact that the black one here is y is equal to x squared. Now what I've noticed is that the vertex has moved to the right 4 and up 2. So my vertex is hk, or we would say that it's at the point 4, 2. My equation, y minus k, is equal to, the coefficient a is just 1, so we can leave it as nothing there, x minus 4 squared. On the bottom here, we've got that y is equal to negative 1/2 x squared. What I see is that my vertex has moved to the left 2 and up 4. So my vertex is at the point negative 2, positive 3. Sorry, I think I said that wrong because we moved to the left 2, up 3. When I write this equation, I will write this as y minus 3 is equal to negative 1/2, because that's right here, we can't drop that, times x minus a negative 2, so that's plus 2 squared. We'll also need to be able to define the axis of symmetry on these graphs. The axis of symmetry is the vertical line that goes through the vertex. So on this one, the axis of symmetry is x equals 4. Here, the axis of symmetry is x equals negative 2. Should be pretty easy to see. There's your 4. There's your negative 2. You will be asked to describe graphs. So here are the things I'm going to look for. First of all, you need to tell me if it's a happy face or sad face. If the A value is not 1, you'll have to tell me if it's fat or skinny. You'll need to tell me the vertex. You'll need to tell me the axis of symmetry. So we look at this first one. Is it a happy face or sad face? Well, coefficient here, A, is 1. Positive 1, so it's a happy face. If you'd like to say opens up, that's fine too. I call it happy face. We're not going to have to identify if it's fat or skinny because the coefficient is 1. The vertex is negative 3, negative 2. And the axis of symmetry is the equation x equals negative 3. Take a look at the next one. The A term is negative 1, so it's a sad face. You can also say opens down because that coefficient is 1. We don't have to give it a fat or skinny. If it had been negative 2, we'd say it's skinny. If it had been negative 1/3, we'd say it's fat. Whole numbers are going to be skinny. Fractions are going to be fat. The vertex will be the point negative 1, 3. Right, so the opposite of this, the opposite of this. The axis of symmetry is x equals negative 1. For these problems, you're asked for vertex and y-intercept. vertex is going to be pretty simple. Here the vertex is -2, 3. Y-intercept is harder. You're going to have to put this in, actually you just plug in a 0 for x and solve. So y minus 3 is equal to -0 plus 2 squared so the y-intercept is -1. Taking a look at the next one, it's not going to be quite as simple as the last one was. We're going to have to do some manipulating on this problem. So we've got y is equal to -2x squared plus 1. Now what I need to do is I need to complete the square. So I'll bring the 1 over. Y minus 1 is equal to -2x squared. And from this point I'm pretty much done. Y minus 1 is equal to -2 times x plus 0 squared. So my vertex is 0, 1. To find the y-intercept, I have to plug in 0 for x. Take a look at this last one. Again, I need to put this into vertex form. So the first thing that I want to do is move this 8. Then I actually need this coefficient of y to be 1, so I need to factor out that 4. And then I know everybody wants to divide by 4, but I'd rather you think about it as multiplying by a 4th. And the reason I say that is because you'll get -1/4 as a. And then you can pretty easily see your vertex. For your y-intercept. Sorry, this is a little messy. So your y-intercept is -6. We should be pretty good with these next two, writing the equation for the parabola. So remember that our vertex is hk, and that the equation is y minus k is equal to a times x minus h quantity squared. So we just kind of plug in numbers for this one. Y minus 5 is equal to 2 times x minus -3 squared. Here we're given the vertex, and we're told the absolute value of a is 3, but it opens downward. Downward means that a really is -3. So we have y minus 0, we can just write that as y, is equal to -3 times x minus a negative 5